Today we're going to try something different. For lesson 3, we're going to work together on the questions. So get your textbook and open to page 390. And we're going to start with question 2. We're not going to do question 1 because we don't have the physical pyramids for you to actually check. So we'll start with question 2. So I've made one very similar to what's in the textbook. And you're going to do it with me. So get out your grid paper and be ready to continue this pattern. We're going to do the next 3 frames after this. So you're going to draw those. And then we're going to do this table together and you're going to continue it up to frame 7. So the first thing we're going to do is make a table because it asks, how is the number of vertices related to the frame number? And then how is the number of sides related to the frame number? So instead of making 2 different tables, I just made one with the frame number here. So we'll figure out the patterns for those in a moment. But let's count it. So how many vertices are there in frame 1? Well, vertices are like your corners. So how many corners are there on a square? There are 4. So I put that one in already. How many sides on a square? There are 4. That one was pretty easy. The next one is a little strange, the way they count it. So I'm just going to do this with a red pen. When they say the number of vertices, they count 1, 2, 3, 4. They only count that one once. 5, 6, 7. So we go down here, and it's going to be 7. Okay. How many sides? They count this very strangely, so pay attention. They go 1, 2, that whole thing counts as 1, 2, 3, 4, 5, and 6. So for this one, there are 6 sides. Okay. Here, how many vertices? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so you should be seeing a pattern emerging here. How many sides? Again, it's counted very strangely, so pay attention. 1, 2, 3, 4, 5, 6, 7, 8. So number of sides is 8. Okay. Next one, how many vertices? And it's good to actually do it with a pen or a pencil so that you can count and not forget one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, and then the number of sides, again, it's counted in the way I was counting. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, the question for part C, it asks, how is the number of vertices related to the frame number? Basically, they're asking, what is the pattern rule for the vertices? So we're just going to ignore the sides right now. I'll just move this over. We'll ignore the sides and we'll just look at the frame and the vertices. So how is it related? Well, the way we find the pattern rule or the function machine is we look for patterns here. Do you see anything happening here? You should notice that it's increasing by 3 each time, correct? So what you're going to do is you know that one of the items in the function machine is going to be times 3. Okay, but there's going to be something else because 1 times 3 is now 4. So we go back to the frame number and we say 1 times 3 is 3, but the answer is 4. So what's the other part going to be? Plus 1. Okay. Now let's look at frame number and the number of sides. So now we're going to ignore this vertices part and we're just going to look for a pattern going on here. What do you notice? It's increasing by 2 each time. So you should know what to put in the box. And there's going to be 2 parts to it. So you can figure that out yourself. You're going to continue this table all the way to frame 7. So the first 4 are here, but you're going to continue it to frame 7, just like you're going to continue this pattern all the way to frame 7. So you do need to draw the next 3 frames. The next question, it says, imagine that this pattern was made with toothpicks. So let's pretend that these triangles were made out of toothpicks. How is the number of triangles related to the number of toothpicks? So again, you're going to make a table. Make a table. We want to know how it's related. The number of triangles are related to the number of toothpicks. So just ignore this perimeter part for now because that's coming in to the next part of the question. But in frame 1, there's 1 triangle and there are, oops, I made a mistake. There's not 5 toothpicks. That is definitely a mistake. Let me just go here. Sorry about that. How many toothpicks would it take to make this? It would take 3 toothpicks. And the perimeter is definitely not going to be 4. The perimeter, the distance around, is 1, 2, 3. Okay, I don't know what I was thinking there. In frame 2, how many triangles are there? There are 2 triangles. How many toothpicks would it take to make that? Well, it would take, let's use the pen so that we can visually see it. It would have taken 1, 2, 3, 4, 5 toothpicks. So let's put 5 here. What's the perimeter of this shape though? Let's delete that. The perimeter is the distance around the outside. So the perimeter of the shape is actually 1, 2, 3, 4. Okay. Okay, let's do frame 3. Number of triangles. There are 3 triangles. Notice that the frame number and the number of triangles are consistent because each time you're just adding 1 triangle. The number of toothpicks that it would take to make this. 1, 2, 3, 4, 5, 6, 7. And the perimeter around the outside. Perimeter is the distance around the outside. So let's look. 1, 2, 3, 4, 5. Now, the question asks, how is the number of triangles related to the number of toothpicks? So the first 2 things we're going to compare is this. So how do you get from here to here to here? How is the number of triangles related to the number of toothpicks? So look for a pattern. Do you see a pattern here? You will notice it's increasing by 2 each time. So you're going to say the number of triangles relates to the number of toothpicks by multiplying by 2, but 1 times 2 is not 3, so there's something else that you have to do, so you're going to figure that out. Okay? So that is part A. But part B, it asks something else. Part B says, how is the number of triangles related to the perimeter? So now let's just ignore this column here. We're going to check the number of triangles and the perimeter. What's happening here each time? This one's a little interesting. It's increasing by 1. So that doesn't really help us much because it's just going to be times 1. So that's not really helping us. So we just need to look at it and see what's happening. It goes from 1 to 3, from 2 to 4, from 3 to 5. So yeah, you could put times 1 in there, but all you really have to do, what's 1 times 1 is 1, and the answer is 3. 2 times 1 is 2, and the answer is 4. So really, all you need to do is put plus 2. You could put times 1, but you don't really need to. Okay? So that's question 3. Let's look at question 4. Next question. So you're going to make a table like this, number of sides, number of diagonals, and number of triangles. And so copy and complete the table. I'm not going to do it for you this time, but I will show you what they're talking about when they say these sides and diagonals. So I'll just show you on this one. So number of sides, well, obviously in a rectangle there are 4 sides. Number of diagonals, they're just talking about this diagonal line, and they've already drawn them for you. Okay, so that's how many diagonals there are. So in this one, there's 1, and in this one, there's 2. And then the number of triangles is just how many triangles are made when you put these diagonals here. Okay, so you're going to fill this in. Number of diagonals, number of triangles. And then it says, how is the number of sides related to the number of triangles formed? So they want to compare this to this over here. So I'm not going to do it for you because I think you can figure it out. I do want you to notice something here though. Just like in yesterday's work, it doesn't start at 1 and move its way up 1, 2, 3, 4, 5. But it does have 4, 5, 6. So if you notice a pattern in the first 3, you can base your answer on that. The next thing they want you to do is predict the number of triangles formed for a 10-sided polygon. Well, let me look up here and see if they have a 10-sided polygon. I think they do. So is this 10? 1, 2, 3, 4, 5. Wait, maybe that's more. 1, 2, 3, 4, 5, 6. Yeah, that's 12. Okay, let's see if they have. Oh, here's a 10. I didn't realize they had it up there. Okay, so let's look. Here's a 10-sided polygon. And if we were, let's take the same approach that they have. So we make a diagonal line to each point. It's a lot easier for me to do this on the smartboard, but I can just draw it easily. Okay, so it asks, predict the number of triangles formed for a 10-sided polygon. So there's this many triangles, but you probably could have predicted it based on what was happening in the first bit. Okay, if you can't predict it, just go ahead and draw it. And then they ask, how many triangles do you think there will be for a 20-sided polygon? So then you have to really think about that one. Okay, so that's the end of that question. The last question we're going to do today is question 5. You're going to need grid paper for this. It says, sketch different rectangles, each with an area of 36 centimeters squared. Record the lengths and the widths in a table, and then graph it on and describe the graph. So let's just talk about this. We've done a lot of this already in the last unit. The length times the width, the area, is going to be 36. So you could go with something simple like 36 and 1. I like to just go up in numbers. So 2 and what? What would half of 36 be? 3 and what? Okay, and there are some more that you can do. So you're going to finish them all. Then you're going to actually draw the rectangle. So you can use your grid paper. It doesn't have to be centimeters. Let's just say units. And so if you have a nice long piece of paper, I don't, but you would make 36 by 1, and you have to actually draw them. Let me try to draw the 12 by 3 because that's probably as big as the paper I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 by 3. I'm not very good at drawing with mouse, but that's okay. Hopefully you will draw with the ruler and your rectangle will not look like that. Oh, I guess I could have done the rectangle tool. I wasn't thinking. Let me try it that way. Maybe it'll look a lot better. Yeah, there we go. That's what I should have done. Oops. Live and learn. Okay, so you're going to draw them and you're going to label them as well. Okay, so don't forget to always label. So if this is 12, we're just going to call it units because you're going to be using the grid paper. And everyone's grid paper is different. Some of them are 1/4 inch, some of them are 0.5 centimeters. Like they're all different. So we're just going to call it units. Okay. The next thing you're going to do is graph it. So the length will be here and the width will be here. So if the length is 36 and the width is 1, we're going to have to come all the way over here to 36 and put a dot at 1. Now mine is not big enough, but yours will be. Let's just try the 12 and the 3 because I might have enough space for that. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then up 3. So there's my dot for 12 and 3. But you're going to graph all of them. Once you've graphed them all, it says describe the graph. Tell me if it's an upward trend or a downward trend. Okay? Once you've done all of these, hopefully you've been doing it with me because now you'll just have to finish up a couple of small things and you will be done your work for today. Have a great rest of the day.